In this session, we are going to see about the introduction to trees and its various terminologies. So generally, our data structures is divided into two different types of data structures. One is a linear, the other one is non-linear. So generally, arrays, linked lists, tags and queues are classified under linear as it is arranged in a sequential form and it has only one level. Whereas under non-linear data structures, we have trees, graphs, and these are represented hierarchically, which has multiple levels. For example, when we consider or when we take an organization, suppose for example, we take college as an organization, we have different levels of hierarchy. To represent our data in terms of hierarchical way, we go with trees. So we have A. So we suppose this is our director, and under director we have different deans. Under deans we have different HODs, and under HODs we have different faculties reporting to. So this is a general hierarchy wherein we represent in terms of trees. Generally, tree is defined as a collection of nodes linked together to simulate a hierarchy. So generally, our tree grows from top to bottom. So this is, we call it as a root node, which is at the start level, and when it processes further, each and every trees are called as nodes. And here we call this can be a subtree, and this from C, G, L, M can be a subtree, and D and H can be a subtree. So we call this as a root node or a parent node. B, C, D are child for this node A. E and F are child for B. Similarly, G is a child of C. H is a child of D. I, J, K are child of E. L and M are child of G. And G is called as a parent for L and M, and vice versa. So we know what a parent is, what a child node is. Okay. So nodes are used to store some particular information. It can be in the form of numbers, strings, character, or any other way that we wanted to represent. The general application of trees is for implementing of a file system, like we have directories, subdirectories, under that we have folders and files. So for implementing a different routing protocols and for organizing our data in a quick search. We'll see now some of the terminologies related to our trees. So first, a root. A root is the topmost element that does not have any parent. So in our example that we have taken, so A is the one which does not have any parent. So all other nodes have a parent. So we call A as a root node. Nodes. It is used to store some information and contain link to the other nodes. So in our example, all these are our nodes. Like even A is a node. So it is a root node. B, C, D, E, F, G, H, I, J, K, L, M, N are all nodes. Parent node. It is an immediate predecessor, in the sense previous of any node. Like G is a parent of L and M. Okay. So we have G, and G is a parent of L and M, and we have parent as for I, J, K, E is a parent, for F, B is a parent, for G, C is a parent, for H, D is a parent, and for B, C and D, A is a parent node. Child node, it is an immediate successor of any node, that is whatever that follows from the node to the next level, that is called as our child node. Here in this example tree, L and M are children of G, I, J, K are children of E node. Leaf node, it is either called as an external node, a node which does not have any children, which doesn't have any child node, we call it as a leaf node. So here in this tree, we have to find out where the node doesn't have a child. So I doesn't have a child, J doesn't have a child, K doesn't have a child. So these I, J, K are leaf nodes. Similarly, F don't have a child node, so F is a leaf node. L, M doesn't have a child, so these two are called as our leaf nodes. Similarly, F and H is nothing but a leaf node. It doesn't have any child. Non-leaf node, it is either called as an internal node. The node which has at least one child node, we call it as a non-leaf node. Here in this diagram, we have non-leaf node as E, B, C, D, A and G as a non-leaf node or internal nodes. That is the nodes which have at least one child. Okay. So these E, B, A, C, D, G. These are called as an internal node or non-leaf nodes. Next is a path. It is a sequence of constructive edge from a source node to a destination node. Suppose I wanted to find a path from the root node to L. So what is a path? It is nothing but a sequence of constructive edges from our source node to a destination node. So what is our source node? It is A to C, C to G and G to L. So this is a path from A to L. The next terminology that we are going to see is our ancestors. It is any predecessor node on the path from the root to that particular node. Suppose we wanted to find out the path of L. So we would like to find the ancestor of L. So here we have L. We have to find what is the ancestor for this L. So ancestor is nothing but any predecessor node on the path from the root node to that node. From this root node to the L. So we have to find what is the path to L. Path to L from the root node is A, C, G and L. This is the path node. So we have the ancestors as A, C and G. The next terminology we see is descendant node. Any successor node on the path from that node to the leaf node is called as a descendant node. For example, suppose I wanted to find out what is the successor for C or descendant for C. So descendant for C is we have to find the successor on the path from that particular node to the leaf node. We have to reach the leaf node. So what is the successor node from this C? So we have the successor as G, and G to L, it takes two paths, G to L and G to M. So the descendant of C are G, L and M. Similarly, for example, if we wanted to find out the descendant for B, so we have B to E, E to I, then J, then K. Similarly, we have from B to F. So these are the descendants for B. A subtree, it is a containing of a tree T and all its descendant. So we call this is whole as a tree, and subtree can be called like a B, E, I, J, K, this whole as one tree, and C, G, L, M as one subtree, and D to H as one subtree. Similarly, from this subtree I can have one more subtree as E to I, J and K. So this is a node containing of particular tree and all its descendant, we call it as a subtree. Next term is sibling. It is all the children node of the same parent. What do you mean by a sibling? Sibling from the same parent. If we have two different nodes, we call these two as siblings. E and F are sibling, and similarly L and M are sibling. But we don't call F and G as sibling because they are from different parents of B and C. The very next important term is a degree of a node. It is the number of children of that particular node, we call it as a degree of node. For example, if we wanted to find out the degree of A from the above example, so we need to find out how many child A has. So it has 3 child. So the degree of node for A is 3. Similarly, when we wanted to find out the degree of node E, it is 3. Degree of node for B is 2. For C it is 1, and for D it is 1. By default, the degree of all leaf nodes will be 0 because it doesn't have a child. So the degree of a tree is termed as the maximum degree of any node among all the nodes. Suppose I wanted to find out what is the degree of this particular tree. So I have to find out what is the maximum nodes of degree for each node. So for A it is 3, for E it is 3, for B it is 2, C it is 1, G it is 2 and D it is 1. So what is the maximum degree? E has 3 and A has 3. So the maximum degree of all the nodes among all the nodes. So it is 3. So the degree of this particular tree is So next is a depth of a node. It is the length of the path from root to that node. That is length of the path in the sense the number of edges from root to that particular node. Suppose I wanted to find out what is the depth of a node F. So what is the depth of a node? It is number of the edges from root to this particular node. How many edges we have from the root node A to F, A to B and B to F. So the depth of a node of F is 2. Suppose we wanted to find out what is the depth of node J. Okay. So what is the length? How many edges it traverses? A to B, B to E and E to J. So there are 3 edges. So we call the depth of a node J is equal to 3. What is the depth of A, the node? It is from the root to that particular node, root to this particular node itself. So the depth of this particular node A is 0. So next is we have to find out what is the height of a particular node. So the number of, it is the number of edges in the longest path from that node to a leaf node. So here for example, suppose I wanted to find out what is the height of node G. So what is the height? It is the number of edges in the longest path towards its leaf node. So from G to its leaf node it is L. So the path is 1. So the height of this node G is 1. Suppose I wanted to find out what is the height of node B. So what is the length? We have to find out the longest length. So to the leaf node we have F as a leaf node, IJK as a leaf node. But we have to find out what is the height. Here it is 1, but when to reach IJ and K it has 2 edges. So the number of edges in the longest path, this is the longest path. So we have 2 edges. So here the height of the node for B is 2. In general, the height of tree is equal to height of root node. Because the height of the root node has the longest path to the leaf node, so that will be the height of the tree. The next term is level of node. So we have to find out what are the levels. So distance from the root to that particular given node, that is distance is nothing but the total number of edges from the root to the given node is called as the level. Suppose I wanted to find the level of node G. So what is the level of node? It is the distance from the root to the given node. So how much distance it travels? It has 1 and 2. So the level of G is 2. Suppose I wanted to find the level of L. So it is from the root to L. So it is 1, 2, A to C, C to G and G to L. It is 3. So the level of a node, each hierarchy we can call it as a level, and level of node is equal to depth of node. Similarly, level of tree is equal to height of a tree. You can cross check. Here the height of a tree is 3. So check out for the level of tree. And in general, if there are n nodes, then it will have n minus 1 edges in general.